So your hypothesis, ionic will probably stay together due to its strong bond. Covalent, based on your knowledge of covalent, it might fall apart. Your materials, ready? Your materials. First of all,
Microscope.
super old microscope. You can just put microscope, you don't have to include the super old.
So you put it in the little...
Yeah, in the little boxes. Microscope. This is a two-parter. What is this thing?
That would be the...
Stand. Good, stand. What kind of clamp have I attached to the stand?
A ring.
A ring clamp. Very good. Only class all day.
Well,
All yesterday and today.
oh.
Everyone else is like circle.
Yeah,
Seriously?
so,
We're the only one?
wait, so are we the only class doing this today?
Yeah. Ring clamp right here. We're not going to utilize the ring clamp, what it's really for. It's just kind of there to help us today. What you really use it for is for holding things. We're going to actually hang something. Okay. What are these? Googles. Googles. Here's your next material. Too small. You must include the word small.
So you don't have the pop on?
No, these are heavier, so they're cooler. Two small paper clips. Small paper clips.
Small.
Small is the key. You will get one lighter.
Yes.
Okay. I am trusting all of you today.
Hopefully it's not a mistake.
You're already. Then I will bring to you. Oh yeah. Losing my mind. I'll bring to you string number 1, or string A. Yes, it is a cotton string. It is. You don't know what I soaked this one in.
We gotta find out.
Alcohol.
No.
Gasoline.
No.
Salt water. Salt water.
Guess not yet.
Yeah, man, if
String
it's
1.
gasoline.
Then you will get a different string.
String B.
String 2, string B, whatever you want to call it, soaked in a different solution.
Why is it all stiff? What'd you do to it?
Bleach.
Candle wax. Wax.
So I soaked them, and then I dried them.
Wait, they're okay to touch?
Yeah, you can touch it.
She's...
Yeah, it's all it is. Okay. When you get your strings, please don't bend them all up. You want them to stay straight. If you start bending them, you're going to ruin what's on there. I will help you understand what's on there in a minute. When you get your string number 1, you're going to take your paper clip. I want the procedures on the backside. Skipping around. You're going to gather all the equipment from the counter and bring it to your table. I did procedure 1 for you. The rest of the procedures I started for you, and you have to intelligently fill them in. Ready? Here's how it goes. Set up the stand and
Ring clamp.
ring clamp, which is kind of already done for you. You just have to check it. Good. Step 3, tie the string to the paper clip. Okay, so you're going to tie it into a little knot on your paper clip as such. You don't have to make the knot super neat or tight. Okay, there it is. It's hanging. The paper clip is weighted. That's what we want. We want it to weight. So you can be like this. Okay. Attach the string to the ring clamp. You're going to tie it to the ring clamp. Tie it on there. Okay, I'm telling you so you know, you don't have to write this down. Your string needs to be hanging above your stand and above your table. Okay, so make sure that's a good height. Make sure it's straight. What's the next one?
Like the
string. Where do you think you're going to light it?
The bottom.
Very bottom. Yeah, heat rises. Remember, it's science. So heat will go up, not down. It's going to go up. So you need to light the knot by the paper clip. And string if it's smoking, or grab the flame. Any of those would do. Also, be careful not to breathe on the reaction. It will ruin it. Don't bump the table. Don't knock the ring stand. It will ruin your reaction. Okay. Observe the reaction. Very good. Good job. Then you record your observations. This is how you record your observations. In your analysis part, you're going to make a T-chart. Quick little T-chart in the back. And you're going to label one side string 1 and one side string 2. This is the part I'm grading most carefully. I want to know if you understand what's going on. So I'm going to really look at your analysis and your conclusion. So you're going to be extremely detailed in your analysis. You're going to explain everything you see. Oh my God, it's so amazing. This is what I saw. This is what I smelled. Please don't taste it.
Don't touch it.
When it's all done, and it's not smoking, it's not glowing, and there's no flame, you can touch it. That's okay, as long as your group decides that you can touch it. You're going to be very, very detailed on the analysis. Then, I'm going to bring you a depression slide. Depression slide. Right? It's not a wet mount, it's a dry mount. It's depressed. So that means
Maylee Ortiz, please return to class. Maylee Ortiz, please return to class.
that means it's depressed. That means it's indented a little. You're going to take whatever the reaction produces, and you're going to carefully put it in a little depression, and you're going to walk over to the microscope, whichever one you can get to carefully, and you're going to look at it. And you're going to draw what you see under string 1. Okay? Yesterday this happened. Okay. I'm assuming you people know how to use a microscope.
What happened yesterday?
We have different microscopes today. Okay? They put it in, and they were like, I can't see anything. It's so dark.
You have to turn on.
Yeah, you have to turn it on. Oh my God, there's light! I need to totally see it! Twice yesterday. Not once, twice. Warning you people, turn this one on. The others you actually have to plug in, and the light comes on automatically. So if you don't plug it in, you're going to be like, this is stupid, I don't see anything. Okay. The best magnification is with the low and the middle. The low and medium magnifications. If you go too high, you're not going to see the bonds in the fibers. Okay? You can try it. Go ahead. I soaked it in a really extreme solution of salt water. Right? So what's completely left behind is what? Salt. Those are just salt crystals that look like a rope because they dried on the rope. It's fine. You can totally touch it now that it's dry. Yeah. Oh, I'll let you run it again. I'll give you another salt rope so you can see it again and be completely amazed. What I want you to do is look at it underneath the microscope and see if you can see the ionic bonds.
Green or green? I just ran out of sorry. So then the salt crystals didn't dissolve.
Right. It wasn't hot enough. Remember, salt burns at 801 degrees Celsius, which is actually 1,473 degrees Fahrenheit. You have to get it so extremely hot to break the bonds.
We need another paper clip.
We just need another paper clip. Use that same paper clip. Go look at it underneath the microscope.
What do we do with these ones? We just clean it off.
Yeah, I'm going to let you run it again so you can be completely amazed again. There you go.
I'm gonna burn this one.
Make sure you're drawing and recording what you see. You're actually looking at ionic bonds. For the second string,
I figured it was.
on your second string, try twisting it.
Twisting what?
Once you tie the paper clip and then tie it to the ring stand, try twisting the string and see what happens when you light it. When it's twisted.
Oh, okay.
It was cool. It's just like
Oh, no, no.
You're all cleaned up.
Okay, sorry.
it's not over here.
You want it like that?
We use the same paper clip.
Yeah, use the same paper clip. same paper clip you just used because we're not contaminating. So try twisting it a little and see what happens. If you twist it enough, it should kind of look like those firework snakes that grow.
Twist it.
Yeah. Once you get the
Oh,
paper.
the other way? Wait, like to loosen it up or tighten it?
Tighten it.
No. Look at it. So like where there's little knots in it?
Yeah.
Like those little things?
Pink it up. See what happens. Try to like that.
Okay.
Like how much?
Another one after this. And everybody else wants to like really show it.
Okay. So then there's one Miss J.
Wait, are you guys doing it again?
Yeah.
Miss J, not like
So now, wait, yeah, once you've twisted it,
This is somebody's.
oh, like tie it in different spots.
the salt should take the form of the rope even though you've twisted it. If you're very, very careful.
Wait, like tighter or looser?
That's good. So it should take that form. That's good.
Like you want it.
That's good. So it should follow the kinks in your rope.
We're supposed to dry.
Okay, follow the twist. Good one.
Oh, we were supposed to twist it?
So it still holds.
This is string C. Wait, how did that one look? Is it all together? The second? Is it all together? Yeah, this one.
Because the bond between the salt is so strong it'll hold even through your twist. Good.
Like just what?
Yeah, it'll spin, but it still holds.
Totally missed the knot.
So that's just the salt.
It's holding the salt and then
The salt is holding the rope.
where it got tight, it held longer.
Because what did the salt do?
It took the form of the rope.
Yeah, and so when it's
And it
twisted,
all
it's
collected in that one spot.
Yep. Pretty cool. So it's holding a significant amount of weight, even with that knot right there.
You're looking at your eyes. Oh my god.
What's wrong with my eyes?
You're like wide. They're like wide open.
Whoa,
That's a
whoa.
good one.
Our first one.
What's up? Phone?
Miss J, we do it again and put knots in it.
Yeah. Don't make the knots too tight.
I won't.
I know, it looks like crystals like splattered.
that you're drawing it to, okay? But not like super tight. You might have to light that knot. Make sure it doesn't touch the string.
Would you like another string and like try doing different things?
Yeah, the string box is on there. Take one. Oh, that's cool. So your bonds are so strong that what did they do? What did they do?
They just held together.
Yeah, even though they're in knot form. That's salt in a knot form. That's cool. I've never knotted it before. Did you guys get a third one?
Is that recording? Ow. Wait, we're not lighting it, so it's okay.
Oh, is it a big one?
Not. Like, just ionic bond should be so strong that it should even hold in that
What I do when lighting candles like that is I just hold the candle sideways like that.
in a knot.
I like how it like stays into the flame and then keeps going, and then it.
So your salt crystals are now in the knot form. So the ionic bond is so strong it can hold them through the knot. Science. You're tying, coming knot. Good. See what happens.
We already did not talk.
Oh, look how strong your bonds are. Sweet. Yeah, don't be dumb would be a great safety rule.
Wait, so which one is the
Covalent is a weak bond.
that was so the first.
So yeah, it's the first one because why? Yeah, because it fell apart. It couldn't hold itself together. Wait, ionic, it's holding itself together. Yeah. Why? How do you know it's salt crystals?
Because you soaked it in salt water and it burned the cotton.
Right. And so, but how do you know that salt? Like, after we burn it, what's happening? Well, what kind of bond is that? I guess is my question.
Ionic.
Ionic. Why is it ionic?
Because it held together.
It held together, and ionic is strong or weak?
Strong.
Strong. So this is all salt in the form of a string. We burned the string away. This is now just salt crystals holding it together.
Just turn these into the.
When you've completed your lab in great detail, turn it into the basket, please. Once you've turned it into the basket, make sure that your lighters come back to me, that you cleaned off your depression slides, and that you wipe your table.
Here's an extra. What do you want?
No. I just need you to understand what you saw. I need your depression slides or regular slides.
I know, but we didn't do that one.
Make sure that all the microscopes are turned off and unplugged, please. Make sure microscopes are unplugged.